So now we are going to study the next concept is moment of inertia of a hollow cone. So actually cones are two types, like what we studied in the last class. So we have studied spheres are two types of spheres. What is the spheres, everybody? Yeah, of course, three types of spheres we studied. So one is what, everybody? Hollow sphere, and another one is what? All of you? Solid sphere. So same way here, we are going to see now moment of inertia of a hollow cone. So hollow cone means whole mass is depend on only surface or it is distributed completely. Everybody? Yes, please. Hollow cone. Hollow means what? It is only depend on whole mass is depend on surface or it is entirely distributed. Please respond, guys. It is entirely no response at all. All of you, please respond. So hollow cone means what? Mass is present only at the surface or it is distributed completely. That is what is my question to you. Yes, Pradosh?
Yes, sir.
What? So you all people know birthday cap. If you, for example, if you see, so that is the example of hollow cone. Will all agree with me? So if you take a birthday cap, you can see happy birthday cone. So that is what is like ice cream cone. You can see without ice cream. So that is an example of hollow cone. So hollow cone means whole mass is present only on the surface or it is distributed throughout the cone. That is what is my question to you. So either it is present only on the surface or it is distributed throughout the mass. Everyone, please respond. I'm asking you question. தெரியுமா தெரியாதா? At least say that.
Only on surface.
Only on the surface. So let me take the radius is capital R here. And the length of this one, the side of the cone is L. Okay, everybody. So now we have to find let me take the mass of the cone is M and radius of the cone is R and length is L. So we have to find the moment of inertia of a hollow cone when the axis of rotation is passing exactly like this. So this is what we have to find the moment of inertia now. So let us see now, if you want to find the moment of inertia, we cannot find the whole mass. So whole mass is M and radius is R. So let me cut a certain, for example, if I take a knife and I'll cut a top ring, next ring, next ring, next ring, next ring. So it will be forming into a rings. Will you all agree with me, everybody? So if I'll cut it into slices,
Yes,
it will form into infinity number of rings. Am I right or wrong? So hollow cone will be containing what? The particular part, if I take for example, that is the elemental ring. So it contains how many elemental rings? Everyone, cone contains
Infinite number of elemental.
infinity number of elemental rings. So let me take particular ring. So this radius is R. Is this radius is remains constant throughout the cone or remains varies? Everybody. The here on R is varies. So let me take this is small r. Understanding? So the ring is taken. Maybe I can take here or here or here. Your choice. So the distance of the ring from the bottom. Let me take it as a x. What is that, everyone? All of you? X. Clear? Yes. Now you can see the ring in our hand. What is present? Definitely it will be having some thickness. Will you all agree with me? Everybody? Ring is having some thickness. Am I right or wrong? Please respond. Yes. So that thickness I will assume as dx. What is the thickness of this one? Everybody? Yes, please. dx. Okay, all of you. So the thickness of the ring is dx. Now we all knows that moment of inertia of a ring. Can anybody tell me what we have already studied? Moment of inertia.
MR.
Yes, please. Which is equals to mr square. If you are not interested, you can. No problem. So please make sure you need to know all the things what we already studied. So moment of inertia of a ring is equals to how much? Mr square. We have already studied. Means when that mr square, when axis of rotation is perpendicularly to the surface and it must be passes through the what? Everybody. It must be passes through the center of mass. Understanding? So that is what. So I have taken one slice of this cone, hollow cone, who is having a radius r, and the thickness of that particular part is dx. Now, So if I cut it and if I make it into that, we'll get a 2-dimensional, 3-dimensional. We have studied already 2-dimensional it is. So 2-dimensional means what is the area of this one? Anybody can tell? The thickness is dx. Yes, Rudreswa. Thickness is dx. Then area of a. What will happen? Circle 2-dimensional one. This total length will become how much? All of you. It will become 2 pi r. So area of that particular ring, which is equals to 2 pi r into what? Dx. That is what you have to remember. Now, so as I said before itself, I asked, so the particular elementary ring, let me take the mass is dm. So what is the moment of inertia of this particular part? Anybody can tell me? Moment of inertia of that particular part. You are all very thing, already many things we have solved till now. So di is equals to what will happen? Dm into r square. Because we all know ring moment of inertia is what? Mr square. We are taking only dm mass. So it will become what, everybody? dm. So I can form many rings, either here or here or here or here or here. I can form any, how many rings? Infinity number of rings I can form. So I will do the integration. Integration of di is equals to integration of dm into r square. So we all know here everything is fine. So we all notice it. This whole mass is depends on what? Area or volume? Anybody can tell me? The whole mass is lying on only on the surface, so that it is depends on only area of the cone or volume of the cone. Anyone? The
Area.
whole mass is depends on whole mass. Whole mass depends on only surface, so that it is only surface. So only surface means what? It is, what is that, everybody? It is actually what? Area. So area means what is that, everybody? Mass per unit area. So mass per unit area, what is the symbol, Pradosh? Are you there, or people are there or not? We are all
Sigma.
existing only correct. So what is the mass per unit area? Everybody. Yes, please. Symbol.
Lambda.
Lambda. Wow.
Sigma.
Extremely very fine. Super. Mass per unit length lambda. Mass per unit area what?
Sigma.
Sigma. Mass per unit volume rho. Adi what we are studying. So we all knows that 1 square meter area. So what is the mass of 1 square meter area? Everybody? 1 sigma. One mass of 2 square meter area. How much it is?
2 sigma.
2 sigma. Mass of 3 square meter area. How much it is? Everybody? 3
sigma.
like that. Mass of 2 pi r dx area. What is the mass of 2 pi r dx area? Everyone?
Pi r
Pi r
dx sigma.
area by 2 pi r dx into sigma. So this is only which is equals to what? Everybody? Which is equals to what? Dm. Clear, everyone?
Dm.
That is what? So integration of di is I, which is equals to integration of dm means what, everybody? Dm means 2 pi r dx.
dx
2
sigma.
pi r dx into sigma into r square. So we all knows that 2 pi is constant, sigma is also constant, and what is remaining? Integration of r into r square. Everybody? r cube into dx. Now, from the integration, you are all very familiar. Is it possible to do the integration of r cube with the dx? Is it possible? This is different dx and this is r. Is it possible to do it?
Oh, sir.
No.
Oh, sir.
Let us replace the sigma now first. So let us see sigma value. What do you mean by sigma? Mass per unit volume, mass per unit area. Am I right or wrong? Please respond. All of you. So what is the unit area of a cone? Area of a cone formula. What you all studied, you tell me. Area of a cone formula I want it. Pradosh? Area of a cone formula. Hollow cone. Pi into r into L. That is the area of the cone. So that is the sigma. Sigma is equals to m divided by pi RL. So I'll replace this one. So 2 pi into sigma value, how much, everybody? M divided by pi into r into L. Integration of r cube dx. Now, is it possible to do the integration of r cube with the dx? Anybody? Is it possible? No, it is not possible. So let us find the relationship between r and dx. So we all knows that this is bigger cone. Will you all agree with me? What is the length of this cone, everybody? What is the length of the side? L. And r is what? Radius is r. Now I take a cut part of this particular part. So this is a bigger triangle and this is a smaller triangle. Now see again, both the triangles are what? Similarity property, which we have used in last class. Same. So now this radius is R and this length is X. So what is that? If their shapes are similar, similarity property, tell me. What is the similarity property? Both triangles are similar. So smaller triangle and bigger triangle are similar triangles. So what is that? Sides are equal. So
Equal.
R divided by R, capital R is equals to, what will happen? X divided by L. So this is what it is. From that, small r is equals to, what is the small r is equals to? Capital R into X divided by L. That is what we have to find by using similarity. Now this value, you can replace it here. So we'll get it 2 pi into, anyhow pi will get cancelled. So pi, can I remove the pi? Everybody, will you all agree with me? You speak means it is good. If I am keep on teaching, what is the use? So 2m divided by RL, integration of R cube means what I can write in place of R cube, all of you. Rx divided by L whole cube into dx. Any problem? Anybody? Ask me. So similarity, by using similarity. Why I am replacing the R? Do you understand it? R, is it possible to do the integration of R with the dx? Everyone? Is it possible to do the R with the integration of dx?
No,
Only x terms can be done with the dx, y terms can be y, r terms can be r. R can be done the integration with the dr, not with the dx. That is what, by using similarity property, I am finding the r. What is the surface area? Area of a cone, hollow cone, everybody. What is the area of a hollow cone? Pi r L. Understanding? So please make sure. That's all now. You can do that now. So what will happen? 2m divided by r into L, integration of, this will become what? R cube x cube divided by L cube into dx. Now something is constant in this. Can you tell me what is the constant? 2m divided by RL. R cube is constant. L also constant. So L cube, integration of x cube dx. So can you tell me the limits from where to where it will vary? Limits. Limit is starting from here. So x is equals to 0. And this last point we used to call as what? X is equals to, everybody?
L.
X is equals to L. So limits is varying from where to where, all of you? Limits is varying from 0 to L. So that's all. Now R cube and R will get cancelled. All of you observe. So what else remaining? Which is equals to 2m divided by L into L cube. How much, amma? Speak loudly. L power 4 R square. Integration of x cube formula. X power 4 divided by 4, 0 to L. So that's all it is. So 2m into R square divided by L power 4 into, in place of x, I will substitute L. L power 4 divided by 4 minus 0 power 4 divided by 4. I don't want to write every time, but still I am writing because at least few will be. So L power 4 cancel, 2 ones are, 2 twos are. So what is the final answer, everybody?
MR square by 2.
Square by 2. So mr square by 2 is the moment of inertia of something which we already studied. Anybody? Yes, please. Moment of inertia of something. Anybody? mr square by 2 is the moment of inertia of a something. What, ra? Disk.
Disc.
That is only the hollow cone formula. So please, anybody having doubt, you can ask me. So this is what? Moment of inertia of a hollow cone. Understand, Rudreswa? Pradosh? Asita? That is. So please solve. Nothing is there. Very simple. See here, it is looks like a three-dimensional. Cone is a three-dimensional, but actually it is a what? Actually, whole mass is depend on what, all of you? Only on the surface. That is why it is not volume. Mass per unit volume not. It is a what actually? Mass per unit
area.
So we have to be very careful because of mass is not existed at the middle. That is why it is mass per unit area. So please very, very careful. Hollow cone. Clear all of you? Mr. Rishi, Sai Karthik, Samayan Manya. Understood? Yes. So that is what, very simple it is. So cut one slice, make dm mass, find the dm, and similarity property you apply it, you will get the replacement of R, and then you go proceed and you will get the final answer. So this is what is the MOI, moment of inertia of hollow cone. So now we are going to study moment of inertia of a what? Anybody? moment of inertia of a solid cone. Now imagine your ice cream cup is without ice cream. Ice cream cone is without ice cream. That is the hollow cone. Now you suppose if you purchase a cone with ice cream, cone ice cream, inside something is present. Ice cream is fully present. So now you tell me mass is only distributed on the surface or throughout the things, throughout the cone mass is distributed. Anybody? Please respond. Mass is distributed throughout the cone or it is distributed only particularly. Everybody? Please respond. Yes. There is no cone symbol actually here. I don't know what is this. Any cone symbol is there? I don't think so. Is it there, brothers, in this? No cone symbol, correct? So that's the problem. That's fine. We can make it. So now I will make it. So if I take this is the cone actually. So now it is a what actually? Completely filled with the mass. It is not empty now. It is already like you can take like a purchased ice cream. You purchase the ice cream and it is completely filled with ice cream. So now you can take again same thing. So let me take the main radius. What is the area? This radius is what I can take, everybody. I'll take it as a R. All of you understanding? So now you tell me mass is present or it is only present on surface or it is distributed entirely. Everybody? Yes, please. It is distributed entire, everywhere. Understanding? So now I will cut a slice again. So now you tell me if I cut a slice. So mass is distributed. So now you will get a ringa disca. If I cut a particular thing, particular slice, I will get a ring or disc. Anybody? Yes, brothers? Mass is distributed. So I will get a ring or disc. Anyone? All of you? Disc. So let me take the height of the cone is equals to h. Height of the cone is equals to h. So if I cut it, I will get a ring or disc. Everybody? I will get a what? Disc. So that is elemental disc. So solid cone present. How many elemental disc? Anybody? How many elemental disc?
Infinity.
Infinity elemental disc. So let me draw the disc here. So definitely the disc is having some thickness. So what is the thickness we can say? Everyone will assume as a what? All of you.
dx.
Dx. The thickness of the disc is dx and its mass is distributed. And let me take the radius of this disc is r. What is the radius of this disc is, everybody? R, small r. Here capital R and here what is the radius of the disc, everyone? Yes, please. Small. And let me take the disc mass is dm. Disc mass is what? Dm. So we all knows that. What is the disc momentum? Anybody? Moment of inertia of a disc. Fastly. Moment of inertia of a
mr
disc.
square by 2.
Yes. mr square by 2. Those who are simply sitting like a dumb fellows, better you can leave and you can sleep. What is the use of simply attending? Mr. Kadri, no use. Life will never change if you are like this. You have to work, man. You have to at least one time, not at least second time you have to be. So mass is distributed throughout the body. So now you tell me it is a 3-dimensional or 2-dimensional. Everybody? Mass is fully distributed. So it is a 3-dimensional or 2-dimensional. Everybody? Yes, please. Mass is fully distributed. So it's not only surface. So it is depends on volume or mass per volume or mass per area. Yes, Rudreswar?
Mass per
Mass per
Mass per
volume.
volume. So mass is
Volume.
distributed throughout. So it is a what actually? Mass per. All of you.
Volume.
Mass per volume. So mass per unit volume. So sigma or lambda or rho. What is that? Everybody. So it is a 3D.
Rho.
So it is a what actually?
Rho.
Understanding rho. So 1 cubic meter volume. What is the 1 cubic meter volume? Mass. 1 sigma. Sorry, 1 rho. 2 cubic
Rho.
meter. 2 cubic meter volume. 2 rho.
2 rho.
3 cubic meter. What is the volume? 3 rho. Understanding? Now we have to find same way dm mass. So what is the dm? Everybody check it. So the moment of inertia of a this particular dm. So di is equals to what is that? Anybody can tell me? What is the disk mass? Disk moment of inertia. Here only I have written mr square by 2. So
2.
here dm mass. M mass means m. Dm mass means what will happen? Everybody. Dm r square by 2. So I can make disk 100, infinity number of disk I can make. So that what we have to apply? Integration. So integration of understanding dm r square by 2. So we all knows that I will put this 1 by 2 outside as it is constant. So I will write dm r square. Integration of di is I. Is it okay? Are you clear, everybody? Please respond. Yes, please. Now, so can you tell me, as we all knows that, what is the volume of this disk? Anybody can tell me? We can find it volume of the disk very easily. I have already taught you. So volume of disk, if you want to find it. So how we can find? Anybody? Formula is what volume means. Can I write as the area into height? Can I write it or not? Please respond. All of you.
Yes, sir.
Yes. So that
Yes,
is
sir.
so dx. What is the volume formula, brothers? Volume of a disk. Sorry, area of a disk. Area of a disk answer. Area of a disk answer, guys. Area of a disk is pi r square. H is dx. So what is the area? Total area is how much, guys? Pi r square into dx. That is the area. So what is the mass of this one? So mass of pi r square dx. How much, Ra? Yes, please. Pi r square dx into rho. That is the mass of this area. Is it okay, guys? No response. So that is what you have to number. So dm mass is equals to 1 by 2 into rho into, what do you mean by dm? Dm means pi r square dx into rho into r square. Are you clear, everybody? Any doubt you can ask me. Are you clear? So as it is very small r, sorry, I made mistake here. I assumed as a small r, but here I written capital R. So it is dm by r square. Dm small r square or capital R square? Everybody. That is radius is what? R, small r. So, but I have taken capital R. So it is small r square, small r square, small r square, small r square. Now what we know that pi is remains constant, sigma is remains constant. Let me take outside. So 1 by 2 into pi into sigma, sorry, rho into r square, how much, guys? R power
4.
r power 4 dx. Now tell me, is it possible to do the integration of r with the dx? Is it possible?
No,
Yes.
sir.
No. So
No,
let me find first volume. Sorry, sigma. Sorry, rho value. So what is the rho value? What do you mean by rho? Mass per volume or mass per area? Mass per
Mass per
volume. So mass is m. Can you tell me what is the volume of a solid cone? Formula, mathematics. Surface areas and volumes is studied. What is the volume of a cone? Total volume. Formula, please. Volume of a cone is 1 by 3 pi r square h. So m3 will go up. So what is the rho equals to? Rho equals to 3m divided by pi r square h. So please write it. So pi into 3m divided by pi into r square into h. So pi will get cancelled. Integration of r power 4 dx. Now r power 4 dx, is it possible to do the integration? We cannot be. So again, same principle. So we are having a large solid cone and we are taking a small solid cone. Now both are similar or not similar? Everybody. Both are similar or not similar? Similar. Understanding? Please respond. All of you. If you are responding only, it will be good. So this radius is small r and this radius is capital R. And this height, I can take it as a x and this height is h. So we all knows that. So can you tell me what it will be happen? All of you? So similarities. If it is similar means ratios are same. So I will say, can I say it? R small r by capital R is equals to small x by h. So small r is equals to r into x by h. Will you all agree with me, everybody? If you agree only,
Yes, sir.
yes, that's all. So I'll replace with that. So I is equals to 1 by 2 is there. So I'll write 3m divided by 2 pi square h. Integration of r place, what I can write, guys? Rx by h whole power 4 into dx. Now can you tell me the limits from where to where? Limits x is equals to 0 to x is equals to what? All of you. X is equals to h. Understand?
0.
Yes, that is the limit. So I is equals to, you can see, all of you, I will write 3m divided by 2 pi square h. So limits is 0 to h. So what will happen? 0 to h. This will become r.
To R square H.
R square.
R square H.
Sorry. This is r square, not pi square. Very good. So r square h. So this is r power 4, x power 4 divided by h power 4 into dx. So something is constant here. Can you tell me what is remains constant? Capital R and h is remains constant. So 3m divided by 2r square h into r power 4 into h power 4 integration of 0 to h x power 4 dx. That's all. You can easily finish it. So what is that, everybody? Here you can see. I will make it everything. So h is I is equals to 3m divided by 2r square h into h power 4. How much, guys? H into h power 4, how much? H power 5 into r power 4. 4 and square will get cancelled. Integration of x power 4, x power 5 by 5, 0 to L. That's all. 0 I won't substitute it directly. I'll go with that. So I is equals to, what is that, Asmita? 3m divided by, 3m r square. 3m r square divided by 2 into h power 5 into directly L I will substitute it. L power 5, L H H power 5. So h power 5 divided by 5. So h power 5 will get cancelled. So I is equals to, what is the answer? Speak loudly. 3m r square divided by 2 5 is how much? 10. So which is equals to 3 by 10 m r square. So please write it. This is the solid cone, moment of inertia of a solid cone, where axis of rotation is exactly passing through this R. This is the axis of rotation. So I forgot to mention you. So this is the axis of rotation. So what is the moment of inertia of this solid cone, everybody? 3 by 10 into m into r square. This is what is about the solid cone. And hollow cone, what is the moment of inertia? Moment of inertia of a hollow cone.
MR square.
Yes, please.
MR square.
mr square by 2, which is equals to what? Moment of inertia of a disk. Clear, everybody? That is what it is. So this is what about hollow cone and as well as solid cone. So both are very simple. Here solid cone is a 3-dimensional one and hollow cone is the entire mass is depends on only area. But in cone, solid cone, it is present on what? Solid cone present on volume. So that is why it is mass per volume, it is rho, and this is mass per area, it is what? Sigma. So don't get confused. Are you clear, Mr. Pradosh? Anything doubt? Rudra, understand? Yes?
Yes, sir.
Yeah. So that is what. So this is what is about moment of inertia. Then tomorrow we are going to study moment of inertia is over with this. Then tomorrow we are going to study different thing. It's entirely different from what we studied till now. So we are going to start in the tomorrow only. Till here anything doubt you can ask me, or else you can leave from the meet. So that is what it is. Okay, Rudresh sir. You understand, everybody, how to solve it? It's very important, NEET and JEE. Pradosh, clear? So imagination is very important. How the mass is depends and all, you have to make it. Okay. So this is what, with this entire momentum concept is completed. Only numericals you have to practice, and then we are going to study. Tomorrow is entirely different concepts we are going to start. So with this, actually half of the chapter is almost completed. Remaining half is pending, and many different. Every year, NEET and JEE, minimum 5 marks I used to notice. Every year, mains, advanced, and NEET, every time, definitely minimum 5 marks they will ask you from this rotational motion. So very, very important. That is what you should stress. Each concept has greater importance. So please learn very effectively. It's not normally you are studying. Okay. So with this, we'll finish it and we'll make it tomorrow. So please carry on. If anything doubt, you can ask me.